Hello, so I'm going to be going through the Unit 9 test review for Algebra 3, and we're just going to jump right in. So this first section says, find the missing side measure using special right triangles, no trig. You have exact answers, no decimals. So in this situation, we have two options. The first option is a 45, 45, 90 triangle. And so when we have a 45, 45, 90 triangle, our legs are kind of what we go off of, and so both of those have the same measure. We notate that by n, and then our hypotenuse is n times the square root of 2. Now additionally, we have another option. We have a 30, 60, 90 triangle, so again 90, 30, 60, and so for that one we're going to go off of the smallest side, so that would be n. The longer side would be n times the square root of 3, and then the hypotenuse is going to be 2 times n. And so that's what we'll go off of. So in this first problem, we have the smallest side. So that means that n is equal to 7. So then we should hopefully notice that, again, this is a 30, 60, 90 triangle. That's why I know that. So the shortest side is going to be n. The longer side would be n times the square root of 3. So that means that x is going to equal n, which is 7, times the square root of 3. And then the hypotenuse is going to be 2n. So that's going to be, so y would be 2 times 7, so y would be 14. So again, in number 2, we also have another 30, 60, 90 triangle. This time, instead of being given the shorter side, which is across from the 30-degree angle, we were given the longer side. So that means that this is equal to n times the square root of 3. So we want to solve for n. So we'd say 12 is equal to n times the square root of 3. And so to solve for n, we would divide by the square root of 3. Now you can rationalize, but you don't have to. So we would get 12 over the square root of 3. If you did end up rationalizing, you should get, I think, 4 square root 3. But I'm just going to leave it like this. So what that actually gave us is this shorter leg length. So that means that x is equal to 12 over the square root of 3. And then again, for that hypotenuse, we're going to do 2 times n. Well, we just figured out what n was. So y is going to equal 2 times 12 over the square root of 3. So y is going to equal 24 over the square root of 3. Again, if you did rationalize that, you should get 8 square root 3. You do not have to rationalize it, which is why I'm leaving it like this. So again, these are our answers. Okay, so we have another 30, 60, 90 triangle. This time we're being given that hypotenuse. So again, that we should hopefully know is equal to 2n. The hypotenuse is always equal to 2n in these situations. So again, we want to solve for n, so we do 5 square root 2 equals 2n. And so to solve for this, we would divide by 2. So it is gross, but it's still a viable answer. So it'd be 5 square root 2 over 2 is equal to n. Again, that is going to be the shortest leg, or the leg across from that 30-degree angle. Okay, so the shortest leg is always across from that 30-degree angle, and the longer leg is always across from that 60-degree angle. So that means that we found that x is equal to 5 square root 2 over 2. And again, that longer leg is going to be n times the square root of 3. So in order to find y, we would have to take that 5 square root 2 over 2 and multiply it by the square root of 3. So we can multiply what's inside the radical together in order to simplify. So we would do the square root of 2 times the square root of 3 to get the square root of 6. That doesn't simplify any further, and so those would be our answers. Okay. This one actually doesn't specify, and so because it doesn't specify, technically speaking, you can't solve it with right triangle trig. But because of the section, I'm going to fix this. So this is actually a 45, 45, 90 triangle. In general, you can't just assume that, but that was just a printing mistake, so just know that that's the case. So if that's the case, then we are given the hypotenuse, and that hypotenuse is going to be equal to n times the square root of 2. So again, we need to solve for n here, so we'd say 12 equals n times the square root of 2. And in order to solve for this, we would divide by the square root of 2 for both of these. So we would get that n is equal to 12 over the square root of 2. Again, you do not have to rationalize. If you did decide to rationalize, you would get that this is 6 square root 2. And so both of the legs in this case are equal to n, so that means y is equal to 12 over the square root of 2, and x is equal to 12 over the square root of 2. So they're equal to the same thing. Okay, so in number 5, we also have another 45, 45, 90 triangle. So this time we're given the leg, so this is going to represent n. So the other leg is also n, so that means in this case x would equal 7. And then again, that hypotenuse is going to be equal to n times the square root of 2. So in this case, y would equal n, which is 7, times the square root of 2. And so that would be our answer. And for the last one, these tick marks mean that this is an isosceles triangle, meaning that these leg lengths are the same. So that also means that these two angles are the same, and the only way that that can work is if both of these are 45 degrees. So we have another 45, 45, 90 triangle. So again, those legs are equal to n, so that means 5 square root 3 is equal to n. I'm going to call this x, so that means that x is also equal to 5 square root 3. And then we need to find that hypotenuse, which again, that hypotenuse for these types of triangles is n times the square root of 2. And I'm going to call this y. So to find y, we would do 5 square root 3, which is n, times the square root of 2. Again, I can multiply what's inside the radical with what's inside the radical, and outside with outside. In this case, I only have stuff on the inside, so y is going to be equal to 5 times the square root of 6. So these would be our two answers. Okay. So the next section says to find each missing measure, write your answer in simplified radical form or as a number round to the nearest thousandths. So thousandths means the third decimal. Let me actually grab a calculator really quick. Okay, so, and again, we don't want to use found measures to find other measures. So I'm going to probably start by finding the side length. So I want to start by finding A. Actually, I am going to find angle C. So in order to find the measure of angle C, that's going to be equal to 90 minus that measure of angle A, right? Because the angles in a triangle add up to 180, but we already have a 90-degree angle here, so that means we can just do 90 minus 52, and that would give us the measure of angle C, which would be 38 degrees. But again, while it's great that we found that, we don't want to use that moving forward to find the other side lengths. So now I'm going to use the angle that I'm given and the side lengths that I'm working with. So again, we're working with SOHCAHTOA here, sine, cosine, and tangent. So in relation to this 52-degree angle, I have the opposite and the adjacent. So because I have the opposite and the adjacent, in order to find the length of A, I'm going to use tangent. So I would say the tangent of 52 is equal to the opposite, which is 7, over the adjacent, which is A. So in order to solve for this, I would have to multiply both sides by A. So I'm going to get A tangent 52 equals 7. And then I'm going to divide both sides by the tangent of 52. So I'm going to get that A is equal to 7 over the tangent of 52. Now we do want to be careful here that we check our settings to make sure that we are in the, that we are in radian. I'm not in radians, in degrees. So we go to document settings and we check that it says angle degrees. So again, you can go to doc and then you can go down to settings, number 7, and then document settings, and just check that you're in degrees. Okay. So now I can go ahead and type in 7 divided by, I'm going to hit this little trig button, and I'm going to go over to tangent of 52. Okay. And so this is going to be the length of side A. So that means that A is equal to, again, 3 decimal places, 5.46, and it's 89, so I'm going to round to 9. Okay, so now we want to find the length of side B. So if I'm finding the length of side B, again, I'm not working with the found measure that I just found. I'm just working with what I'm given. So I have the opposite and the hypotenuse. So this time I'm going to be using sine. So for this one, I would say the sine of 52 is equal to the opposite over the hypotenuse. So again, kind of like the last one, I'm going to have to multiply both sides by b, and then divide by the sine of 52. So b is equal to 7 over the sine of 52. And then I can go ahead and just plug that into my calculator. So again, I'm going to say, sorry, there's a glare, 7 divided by trig sine 52. And that is going to give me that b is equal to 8.883. And it doesn't give us units for those side lengths, so it's okay to leave it like that. So we found A, B, and the measure of angle C, and so we found everything in that triangle. Okay. Now we're going to do this again. So this time we're not given either of the angles, but we are given 2 of the side lengths. So we are going to use Pythagorean theorem in order to find that third side length. So Pythagorean theorem says the sum of the legs squared, so n squared plus 10 squared is equal to the hypotenuse squared. So we would say n squared plus 100 is equal to 256. I'm going to double check that number. Yeah. Oh, I said 256 and then I didn't write it. Okay, so now we're going to subtract 100. And so we're going to get that n squared is equal to 156. Does this want it in radical form? I'm going to simplify this in radical form. So that means that n is equal to the square root of 156. So we want to see if 156 simplifies. There's a couple of ways to do this. You can look for the highest perfect square. Some of my students know that I do the birthday cake method. I'm just going to do that really quick. So 156 is divisible by 2. And so when we do that, what is that? 78. That's also divisible by 2. Which would be, I believe, 39. That one is divisible by 3, which would be 13. That one is just divisible by 13, and so that would be 1. So the 2's can come out. So this would be 2 times the square root of 3 times 13, which is 39. So 2 square root 39. If you did plug that into your calculator, you would get kind of a funky decimal. So if you did hit Control and then the x squared button, that would give you the square root, and then 156. 156. This is approximately 12.4. Ooh, it rounds 490 because it's going to be 8999, so that 9 would round up. So that's going to round to 0.490. So just know that on like a multiple choice section, you may see it either way. So you need to know how to find it either way. So again, now we want to find the angle measure. So I'm going to start by finding the measure of angle n. So again, we're working with only what we're given. So here I'm given the adjacent and the hypotenuse. So that means I want to be working with cosine. So that means the cosine of n is equal to the adjacent, which is 10, over the hypotenuse, which is 16. So in order to find the measure of angle n, we have to take the inverse cosine of 10 over 16. So again, I would go over to my calculator. This time I'm going to hit trig, but I'm going to select the inverse cosine. And then I'm going to do 10 divided by 16. And so that's going to give me that the measure of angle n is equal to 51.31. Again, it'll round to 8 degrees. And then I'll do the same thing to find the measure of angle m. So to find the measure of angle m, this time I'm given the opposite and the hypotenuse, so this time I'm going to be using sine. Oh, I didn't mean to write that. So the sine of m is equal to the opposite over the hypotenuse. So to find the measure of angle m, you're going to do the inverse sine of 10 over 16. So again, we'll use our calculator. So we're going to hit trig, inverse sine, 10 divided by 16. And so we're going to get that the measure of angle M is equal to 38.682 degrees. And you should be able to add these two numbers together and get really, really close to 90, if not exactly 90 degrees. So that is kind of a nice way to check yourself. Okay, moving on. So we want to draw a triangle and label the side lengths of the other 5 trigonometric ratios. So we are given here secant of theta. So a couple of things we may need to know is our trig identity. So you may want to go back and look at those. So secant is the flipped version of cosine. So if cosine of theta is equal to the adjacent over the hypotenuse, that means that secant of theta is equal to the hypotenuse over the adjacent. I got kind of close. So we're going to go ahead and draw our figure. I'm going to just call this one theta. And so what this has given us is that our hypotenuse is going to be 25, that our adjacent is going to be 24, and that we need to know what this side is in order to fill out the rest of these trig ratios. So I'm going to call this x. So we would have to use the Pythagorean theorem to do so. So we'd say x squared plus 24 squared equals 25 squared. So this would be x squared plus, make sure I don't mess that up. Yeah, 576 equals, I believe, 625. Yeah, 625. So then we would subtract 576. And we should get that x squared is equal to 49. Okay. Whew. So then we would take the square root of that to get that x is equal to 7. And so then from there, we can find the other trig identities. So again, we know cosine is adjacent over the hypotenuse, so we can really just flip this to get adjacent, which is 24 over the hypotenuse, which is 25. Sine is the opposite over the hypotenuse, so opposite of 7 over the hypotenuse of 25. Cosecant is going to be the flipped version of sine, so cosecant is the hypotenuse over the opposite, so that's going to be 25 over 7. Tangent is the opposite over the adjacent, so 7 over 24, and cotangent is the flipped version of that, 24 over 7. And so that would be our answer there. Okay, moving on to the next one. Now we have cosine, so again, you need to know your trig identities. Cosine is equal to the adjacent over the hypotenuse, so that's going to help us draw our figure here. Okay, so for our figure, I'm going to again just call this theta. If we have the adjacent, that's going to be 4. And the hypotenuse, that's going to be 7. So again, we need to find this missing side length. So we'd have to do x squared plus 4 squared equals 7 squared. So here we would do x squared plus 16 equals 49. From here we would subtract 16 from both sides. So we'd get that x squared is equal to, what, 33? And then we would take the square root of that. So we'd get that x is equal to the square root of 33. So it's not super pretty, but it does still work out. Oh, I think this is meant to say sine. Let me actually check that. Yes, it is. So this is meant to be sine. And so the sine of theta is going to be the opposite over, before I do sine, I'm going to do secant, right, because secant is the opposite of cosine. So that one we should hopefully know for sure. So instead of 4 over 7, secant's going to be 7 over 4. And then I can move to sine. Sine is going to be the opposite over the hypotenuse. So sine is going to be the square root of 33 over 7. Cosecant is the flip version of that. So the cosecant is the hypotenuse over the opposite. So this one would be 7 over the square root of 33. If you were to rationalize that, you would get 7 square root 33 all over 33. Tangent is the opposite over the adjacent, so it would be the square root of 33 over 4. And cotangent, again, is the flip version of that, so it would be the adjacent over the opposite, so it would be 4 over the square root of 33. Okay, so the next section says draw and label a diagram to represent each problem if one is not given. Solve each problem round answers to the nearest thousandth. So again, that's the third decimal. So a ladder leaning against the side of a house forms a 63-degree angle with the ground. The foot of the ladder is 6 feet from the house. Find the length of the ladder. So we have a ladder going on. It's been leaned up against a wall. And so the things that we know is that it forms a 63-degree angle with the ground. So that means that this is going to be our 63-degree angle. We know that the foot of the ladder is 6 feet from the house. So we know that this distance, if this is the house, oh, I don't want to draw that. If this is the house and this is the ladder, then that this is 6 feet. And it says it wants to find the length of the ladder, so we'll call this x. So we're still using SOHCAHTOA here. So in relation to this 63-degree angle, we have the adjacent and the hypotenuse. So that means we're going to be using cosine. So we say cosine of 63 is equal to the adjacent over the hypotenuse. And again, we're going to solve for x here. So we'd multiply both sides by x, and then divide both sides by the cosine of 63. So we get that x is equal to 6 over cosine of 63. And then again, we just plug that into our calculator. So we'd say 6 divided by the cosine of 63. And so we should get that hypotenuse is 13.216. And so we would say the length of the ladder is 13.216. We want to make sure to include units feet. Okay, and then on to the next problem. Okay, so a safety regulation states that the maximum angle for a rescue ladder is 62 degrees. A fire department's longest ladder is 120 feet. What's the maximum safe rescue height? Okay, so let's again draw our picture. So we know the maximum angle of a rescue ladder is going to be 62 degrees. So that's the largest angle we could have. We know that the longest ladder itself is going to be 120 feet. So we want to figure out what's the maximum safe rescue height. So how high they could rescue someone. So again, for this one, we're going to have the opposite and the hypotenuse. So we're going to be using sine. So we'd say the sine of 62 is equal to the opposite over the hypotenuse. So to solve this one, we would multiply by 120. And so we get that 120 times the sine of 62 is equal to x. So again, we'd hop back over to our calculator, and we would say 120 times the sine of 62. And so we would get that x is equal to 105.95. Again, we'd round properly to 4. So we'd say the max height is 105.954. Again, we want to include units feet. Okay. So moving on to the next one. A rescue team 650 feet away from the base of a vertical cliff measures the angle of elevation for the top. Sorry, give me 1 second. Okay. A rescue team 650 feet away from the base of a vertical cliff measures the angle of elevation for the top of the cliff to be 62 degrees. Matthew has fallen from the top of the cliff and is stranded on a ledge that is at an angle of elevation of 67 degrees. How far did he fall? So we have two different measurements here. So this is our cliff. This is the very top of the cliff. Okay? And so we're kind of standing, so the rescue team is standing here, this is them, and they are 650 feet away from that base of the cliff. Okay, so this is the rescue team. The angle of elevation for the top of the cliff is 62 degrees. So that means that this angle right here, this whole thing, is going to be 62 degrees. Okay, but Matthew falls off the top of the cliff and is stranded, so he falls down to about, say, here, and this is at an angle, this part, of 47 degrees. Okay, so we know that this whole length we can call, or well, we're going to call the whole length the Z. We know that this length right here, we'll call that's how far he's fallen, we'll call that Y, and then we'll call this little length X. Okay, so we have a lot of things we need to figure out. We need to figure out the total length, and then we need to figure out how much he has left, and then we need to like subtract them. So I'm going to start by finding the kind of like little length here. So I'm going to start by finding X, so I'm looking at this smaller triangle. So for this one, I'm going to have the opposite and the adjacent. So that means I'm going to be using tangent, so I'd say the tangent of 47 is equal to the opposite over the adjacent. So then I'm going to multiply both sides by 650, and so I'll get that X is equal to 650 times the tangent of 47. I'm not going to plug that in yet until I get down to being able to type in my final answer. So then I'll move on to the bigger triangle. So I'm going to find this long length, this whole thing, this Z. So again, I'm working with 62 degrees now. And again, I have the opposite and the adjacent. So I'm still using tangent here. So tangent of 62 this time is equal to the opposite over the adjacent, which is 650. So again, we would multiply 650 on both sides. In order to get Z. But we want to find Y. We want to find the distance that he's fallen, which is this distance right here. So in order to do that, we need to take the total distance of the cliff. We need to take the total distance of the cliff and subtract how much of the cliff he has left. So that X. And that would allow us to solve how far he's fallen. So that means we're going to do 650 times the tangent of 62 minus 650 times the tangent of 47. And that's what we're going to plug into our calculator. If my calculator would stop shutting off on me. Okay, so 650 times 650 times the tangent of 62 minus 650 times the tangent of 47. Okay, and so that's going to give us 525.433. So he fell 525.433. Again, we want to include units, and he fell in feet. Okay, we got a lot of ladders in this one. So ladder 12 meters long, resting upon the ground, reaches a point 11 meters high upon a vertical wall. Find the measure of the angle formed by the ladder and the ground. So basically, we have a ladder leaning against a wall that it's leaning 11 meters high, but the ladder itself is 12 meters long. And it's resting upon the ground. So when it says resting upon the ground, it's not like laying flat on the ground. It just means it's resting here, and we want to find this angle. I'm going to call this theta. Okay, so in relation to this angle, we have the opposite and the hypotenuse, so that means we're going to be using sine. So the sine of theta is equal to the opposite, which is 11, over the hypotenuse, which is 12. So to find the measure of angle theta, we would have to take the inverse sine of 11 over 12. And so then we would just plug that into our calculator. So we'd say trig. We'd go down to inverse sine, and we would say 11 divided by 12. And so we would get that the measure of angle theta is equal to 66.444, because again, proper rounding, degrees. Okay. So a high wire is anchored 5 meters from the foot of a pole. The wire makes an angle of 63 degrees with the ground. How far up the pole is the wire attached? So basically what we have here, I think this is meant to say a high wire, not a guy wire. Whatever. Okay, so basically what we have here is we have a pole that's happening, and we have a wire that is anchored to the ground. So it's anchored 5 feet away from that pole, and it makes a 63-degree angle with the ground. So this here is going to be 63 degrees. And we want to figure out how far up that pole the wire is attached. So in relation to this 63 degrees, we have the opposite and the adjacent. So that means we're going to be using the tangent. So the tangent of 63 is equal to the opposite over the adjacent. So again, to solve this, we would multiply both sides by 5. And so we would get that x is equal to 5 times the tangent of 63. Oh, I should be putting little degree symbols here. Sorry, I'm just going back and put my degree symbols, because I did drop them. Okay, I think that's what. Okay, so then we'd hop over to our calculator. And so we would say 5 times a tangent of 63. And so we would get that x is 9.813. Okay, so we can again say the wire is 9.813. This time we're in meters up the pole. So again, make sure you're paying attention to those units. And we have another ladder. So a ladder 16 feet long leans against a building and makes a 70-degree angle with the ground. So we have a ladder. Ooh, that's not a great triangle. That's 16 feet long. It makes an angle with the ground of 70 degrees. And we want to figure out how far up the building the ladder reaches. So we want to figure out this. So again, we have the opposite and the hypotenuse. So again, we're going to be using sine this time. So the sine of 70 degrees is equal to the opposite over the hypotenuse. So to solve for x, we'd multiply by 16. So we'd get 16 sine 70 is equal to x. And again, we'll plug that into our calculator. Okay. And so we should get that x is equal to 15.035. And so it reaches 15.035. Again, we want to include units, feet. Okay, so a plane rose from takeoff and flew at an angle of 11 degrees with the ground. When it reaches an altitude of 500 feet, what is the horizontal distance the plane has flown? So we have a plane, and it like goes, and then it takes off. And when it takes off, it's taking off at a degree of 11 with the ground. Okay, we know that it's going to reach an altitude, so that means a height of 500 feet. But we want to figure out how far horizontally it went. So this time we have the opposite and the adjacent, so we're working with tangent. So we'd say the tangent of 11 is equal to the opposite, which is 500, over the adjacent, which is x. So we multiply by x, and then divide by the tangent of 11. God, I keep dropping these little degrees. So x is equal to 500 divided by the tangent of 11 degrees. And that's what we would plug into our calculator. So we'd say 500 divided by the tangent of 11 degrees. And so we would get that it went 2,572.277. So it went 2,572.277 feet. Because again, we're talking in feet. So we want to make sure our units are consistent. Okay, on to the next page. So we want to convert the following between radians and degrees. So looking at this first one, to convert to radians, we would multiply by pi over 180. Okay. And so then we have to reduce. So the first way we can reduce is, hopefully we notice both of these two numbers are going to be divisible by 5. And so that's going to give us 36 here. And for this one, it should give us, I believe, 31. Yeah. And then those two don't really simplify any further. So this one would be 31 pi over 36. And then we want to convert this one into degrees. So in order to convert into degrees, instead of multiplying by pi over 180, we multiply by 180 over pi. So here, we both know that 180 and 8 are divisible by, what am I thinking of? They're divisible by 2, which is probably where I would start because they are kind of big still. So that would be 90 over 4. Those are also even further divisible by 2, so that would be 45 over 2. And the pi's would also end up canceling in order to get us into degrees. So you would do 45 times 5, which would be what? 225, I believe, 225 over 2. Which, if you wanted to write as a decimal, would be 2.5. And I would probably, oh, that's gross. I would probably prefer it this way. It's probably going to show up as a fraction on your test, but just know that both of these are the same thing. Okay, so now we want to find the reference angle. And so there's a couple of different ways to do this. So for this one, 5 over 3, we're talking about 1 2/3. So for some of my students, it does help to kind of draw it out. I don't know if I have a pencil that works. It does kind of help to draw it out. So we should hopefully at least know that this is 0, this is pi over 2, and then this is 3 pi over 2. So for some of my students, it really does help them to go 0 to pi. Okay, I'm looking for thirds, so I'm going to split this into thirds. So 1/3, that would be 2/3, and then 3/3. And we can kind of do the same for the other side. So if I'm looking for 5/3, I'm going counterclockwise. This is 1, 2, 3, 4, 5/3. So this right here would be my angle, my terminal side. Okay, so I can kind of get rid of the rest of these. Again, you can also think about it in terms of 1 2/3. So going around, this would be 1. And then this is 2/3 of what's left. So then my reference angle is going to be this little piece. Reference angles are always positive, and that's how much I have left. So again, we call that theta prime, and that theta prime is going to be equal to pi over 3, because I have 1/3 of that left. So similarly for this one, again, you can kind of do the same thing. You can think about this as 1 1/6. Again, some of my students like to actually split it physically into 6. And if you want to do that, that's totally fine. So this would be 1, 2, 3, 4, 5, 6 in that first upper piece, and then 1, 2, 3, 4, 5, 6 in that second. And we're looking for 7 of those. So again, we're going counterclockwise. So 1, 2, 3, 4, 5, 6, 7. So this would be the correct side here. My correct terminal side. And so then you can kind of erase all this. Again, you can also think about this as, okay, this is 1, and then 1/6 more. And so all we have left, our reference angle, is going to be right here. And so that reference angle, that theta prime, is going to be pi over 6, because we just have 1/6 there. Okay. So now we want to find a positive and a negative coterminal angle. So in order to do this, we want to add or subtract 2 pi. So I'm going to start by finding a positive one. So for 3 pi over 4, I am adding 2 pi to that. So, but when I do add that, I have to get a common denominator. So I need to rewrite 2 pi as 8 pi over 4 plus 4. So that means my positive coterminal angle is going to be 11 pi over 4. And then I still need to find a negative one. So I'm going to do 3 pi over 4 minus 2 pi. But again, we need to write it with that common denominator. So minus 8 pi over 4. So my negative coterminal angle would be negative 5 pi over 4 for that one. So I have a negative and a positive. Okay. So moving on to the next one, again, I would need to do the same thing. So I need to find a positive and a negative. So I would do 55 pi over 34, and I would add 2 pi. Again, I'm going to need a common denominator. So I can do that by multiplying this 2 pi by 34. And so that's going to give me 68 pi over 34. So then my positive coterminal angle is going to be what? 100. 123? Yeah. 123 pi over 34. Okay. So then I need to find the negative, so I need to do 55 pi over 34. And this time I'm going to subtract that 2 pi, which again we know is 68 pi over 34. So when I subtract that, what is that going to be? 55, 5, 8, negative 13? Yep, okay. And so those would be my 2 angles. Okay, so now we're getting into trig. So we need to be a little careful here. So this is working kind of with the unit circle. So we need to think about our unit circle, what our values are. It may help us to be able to draw it if we can. So again, we're going back and referencing, let me pull it up real quick. We're referencing this information. So this information here is what we're really concerned about because again, we have those reference angles. So just be really careful there and you're going to have to study. So I'm trying to find the cosine of pi over 3. So that's in the first quadrant. Cosine is positive there. And again, you're just going to have to look at that kind of unit circle and study it. The xy is cosine sine. So at pi over 3, cosine is going to be 1/2. And I'll reference back to it. But pi over 3, cosine is the x value, it's 1/2. Okay, so the cosine of pi over 4 is 1 over the square root of 2. Again, pi over 4, cosine 1 over the square root of 2. The sine of pi over 6, that is 1/2. So again, that's in the first quadrant, sine is positive there, pi over 6, that's going to be 1/2. The sine of pi over 4, it's the same as the cosine, it's 1 over the square root of 2. So again, pi over 4, sine is 1 over square root 2. The cosine of pi over 6 is going to be the square root of 3 over 2. So again, we're looking at pi over 6. That would be the x value, square root of 3 over 2. Sine of 2 pi, that means we've made a full rotation around the circle, and so that means it's going to take us back here. So sine there is, again, the y value. It's going to be 0. The cosine of pi, so that's taking us just halfway around the circle to here. Cosine is the x value, so it's going to be negative 1. The cosine of pi over 2, it's talking about that top piece, and the cosine there is 0. Sine of pi over 3, again, still in that first quadrant. So sine of pi over 3 is here. It's the y value. It's going to be the square root of 3 over 2. Sine of pi over 2 is up at the top again. It is the y value. It's going to be 1. Sine of 0 is where we're starting, and sine of 0 is actually 0. Okay. Similarly, sine of pi, that's taking us halfway around the circle, but it is also 0 there. So just make sure you're studying that. There's really not necessarily a trick to that other than to really study it. Okay, so we already did this, but we're going to do it again. So if cosecant is equal to 13 over 5, draw a triangle, label the side lengths, and find the other 5 trigonometric ratios. So cosecant, we should hopefully know, is the opposite of sine. So again, sine is the opposite over the hypotenuse, which means that cosecant is the hypotenuse over the opposite. So when we draw our triangle, again, I'm just going to call this theta, we should know that the hypotenuse is going to be 13, and the opposite is going to be 5. So then we can use that information to find our missing side. I'll call that x. So 5 squared plus x squared equals 13 squared. So 25 plus x squared equals 169. We'll subtract 25. And so we'll get that x squared is equal to 144. And so that should give us that x is equal to 12. So now we can find our other trig ratios. So again, sine and cosecant are opposites of one another, so that means that even without doing this, we should hopefully at least be able to get sine, because it would be 5 over 13. So cosine is the adjacent over the hypotenuse, so that's going to be 12 over 13. Secant is the flip version of cosine, so that one would be 13 over 12, or the hypotenuse over the adjacent. Tangent is the opposite over the adjacent. And cotangent is the adjacent over the opposite. Okay, now we're going to get to graphing. So we want to graph one full period and answer all the questions, label all the points on each axis. So for this one, starting here, if we don't have a number written out front, we assume that our amplitude is 1, because technically that has a coefficient of 1. Additionally, if we do not have a b value, so if we do not have these two with a b outside, then our period would be 2 pi, because it would be like 2 pi divided by 1, which is just 2 pi. So we do not have a vertical shift here. A vertical shift would happen on the outside, but we do have a phase shift because it says x minus pi. That means we're shifting to the right pi. Okay. Our domain, as always, is going to be negative infinity to infinity, and our range is going to be the negative amplitude to the positive amplitude. There is no need to worry about shifting up and down because there is no vertical shift. So that means we're going to draw this. We also need to figure out our increments. And so our increments, we would do 1/4 times the period, so 1/4 times 2 pi. So our increments will be in pi over 2. So first we're shifting to the right by pi. And then from there, we want to add pi over 2 each time. So in case you're struggling with fractions, another way we can write pi is 2 pi over 2. So my next tick mark from there should be 3 pi over 2. From there it would be 4 pi over 2, which would give me 2 pi. From there it would be 5 pi over 2. And from there it would be 6 pi over 2, which is 3 pi. Again, that gives us 1, 2, 3, 4 increments. So cosine, does not start on that, like, what I call the reference line, which here would be just the x-axis. It starts at the amplitude, and again, because it's positive, it's going to start at the positive amplitude. So it's going to start at 1, okay? Then it has to hit that reference line. Then it goes to the negative amplitude, back to that reference line, and it always ends back where it starts. And so the graph of this cosine graph would look like this. Okay, moving on to the next one. Okay, so this is where it gets a little more complicated. So we work with that 2 out front. So that 2 is still our amplitude. Okay, we do have a negative there. That tells us that it's technically a reflection over the x-axis, which I'll get to that more when we graph. So our period we would find by doing 2 pi divided by b, which in this case is 2. So that means our period is going to be pi. Our vertical shift, we have a shift up 1. Our phase shift is going to be the right pi over 2. I'm sorry, pi over 8. Our domain doesn't change. And then our range is always negative amplitude to positive amplitude, but then we're shifting up 1, so we need to add 1 to both of these. So that means our range here would be -1 to 3. Okay, and then we can go ahead and graph it. Okay, so I do need to find my increments. I know I'm going to the right pi over 8. And again, to find my increments, I'm going to do 1/4 times pi, times my period, which is going to give me pi over 4. So that means to this value, I am adding pi over 4 each time. I don't have a common denominator, so I need to make sure I can rewrite this with a common denominator. So writing pi over 4 with a denominator of 8 would give me 2 pi over 8. So that's what I should be adding each time to get my proper increments. So pi over 8 plus 2 pi over 8 would give me 3 pi over 8. I would add 2 pi over 8 to that to give me 5 pi over 8. I would add 2 pi over 8 to that, which would give me 7 pi over 8. And I would add 2 pi to that, which would give me 9 pi over 8. And that would give me 1, 2, 3, 4 increments, which is what I want. I'm also shifting up 1, so I want to make sure that my reference line is happening kind of at 1. And then I'm going to go for there. So again, cosine does not start on that reference line. Cosine usually starts at the amplitude, but because this one is negative, instead of starting at the positive amplitude from that line, it's going to start at the negative amplitude from that line. So it's going to start 2 below this line. Or you can think about it as it would start at -2 and you're shifting up 1. Either way, you should get that it starts at -1. So it's starting here. Okay. So it starts at the negative amplitude because again it's negative out front. Then it has to go to the reference line. And then it will go to the positive amplitude. So it'll go 2 above this line, which would take us to 3. And then it goes back down to that reference line and then back where it started. And so that would be our graph. So you can think about it as transformations or you can work on the pattern. Either way, it works the same. Okay. Moving on to the next one. Again, we don't have a number out front, so there is a 1 out front. That's what our amplitude would be. We also don't have a b value, so again it would be like 2 pi over 1, which means our period is going to be 2 pi. We also don't have a vertical shift here again. We do have a phase shift. We're moving to the right 3 pi over 2. Our domain is still the same, negative infinity to infinity, and because I don't have that any shifts up or down, my range is going to be negative amplitude to positive amplitude. And again, to find my increments, I'm going to do 1/4 times 2 pi, which is going to give me pi over 2. Okay, so now I can go ahead and graph. So again, I'm starting to the right 3 pi over 4. I'm sorry, 3 pi over 2, and to that I'm adding pi over 2 each time until I have 4 increments. So if I add pi over 2 to that, they do actually have the same denominator, so that's great. So that would give me 4 pi over 2, which reduces to 2 pi. Then I would have 5 pi over 2, 6 pi over 2, which reduces to 3 pi, and 7 pi over 2. So again, I have 1, 2, 3, 4 increments, so I'm good to go. So my reference line here is just on that x-axis because I didn't shift up or down. And because I'm working with sine, sine always starts on that reference line. So here it's going to start at 0. And there's no shift up or down, so it's going to stay there. So because this sign is positive, it's going to go to the positive amplitude first. So it's going to go up to 1, and then it will come back down, and it goes to the negative amplitude next, and then it always ends back where it started. And so this would be one period of that graph. Okay. So again, amplitude is always positive, so here our amplitude is 3. The period we would get by doing 2 pi divided by 2. So the period here is pi. The vertical shift, this time we're going down 1. The phase shift, I'm going to the left pi over 2. So be very careful about whether you're going to the right or to the left. The domain is still negative infinity to infinity. Again, our range would normally be the negative amplitude to the positive amplitude, but again, I'm shifting down 1. So I need to subtract 1 from both of those in order to get that my range is actually -4 to 2. And again, to find my increments, I'm going to do 1/4 times pi, so my increments are in pi over 4s. So I want to give myself a little bit of room on the left side, just because I know that I'm actually shifting to the left by pi over 2, so I'm going to start at negative pi over 2. Again, we don't have the same denominators here, so we need to rewrite one of these with the same denominator to kind of help us out. So negative pi over 2, I can rewrite as negative 2 pi over 4 to help me get those increments properly. So if I add pi over 4 to that, that's going to take me to negative pi over 4. If I add pi over 4 to that, that would take me to 0, which is right here. If I add pi over 4 to that, that's going to take me to pi over 4. If I add pi over 4 to that, that's going to be 2 pi over 4, which would reduce to pi over 2. And again, now I have 1, 2, 3, 4 increments, so I'm good to go. Again, my graph has also shifted down 1, so my reference line is going to happen at -1, which is like kind of in the middle of this, but that's fine. So it's happening like here. It's a little hard to tell. Okay. So again, sine always starts on that reference line. So, or you can think about it as it always starts 0 and then it would shift down 1. So it's going to start right here. Okay. And then it would normally go to the amplitude, but it's negative. And so that means it's a reflection. So instead of going up to the positive amplitude from this line, it would go down to the negative amplitude. So you can think again about it two different ways. You can think about it going to -3 and then shifting down 1, or you can think about it as it has to go down 3 from this line. So that's going to take us to -4. It has to go back up to that line before it can go to the positive amplitude, which again you can think about it as going to +3 and shifting down 1, or going 3 up from this line. Either way, it will take you to 2. And then again, you always end back where you started. So this is what that graph would look like. Okay. So now we want to write the equations. It's either a sine or a cosine equation. So when we do this, we need to identify one period. And so one period is what happens when the graph does not repeat within that period. So let's say I'm going to pick here. I typically either pick a positive or a negative amplitude to kind of help me out. And so I want to look and say, where does this start repeating? Well, it's going to start repeating here. So this is where that one period is going to end, because within this period, there is no repeat of this kind of wave. Okay? So then we need to look at a couple of things. We need to figure out what the period length is, what the amplitude is, whether it's a sine or a cosine graph, kind of all of that information. So we can kind of draw the reference line that's cutting this graph in half. So that's actually happening right here, which this is 1, 2, 3, 4. So this has gone down 4. We should hopefully note that this graph is not starting on that reference line. And so because it's not starting on that reference line, it's cosine. And because it's starting, in fact, below that reference line, it's going to end up being a negative cosine. So there is a reflection there. Additionally, we can look at this, and our amplitude is this distance right here. Or you can also think about it as this distance. It's a distance from that reference line to the highest point of the graph, or the lowest point. And so in this case, that amplitude is equal to 2. Or again, you can also think about it as the half the distance from the highest and the lowest point. So we have that it's down 4, it's cosine, and that our amplitude is 2, but we still need to figure out our period. So we need to look at kind of this x-axis. So we should see that, okay, this is pi over 2, this is 3 pi over 2. So it makes sense that in between those you have 2 pi over 2, which is pi. And then beyond that, you would have 4 pi over 2, which is 2 pi. And that is where our graph ends. So that means that our period, oh, I don't want to write in that color. That means that our period is 2 pi. And hopefully we remember the way we get period is by doing 2 pi divided by b. And so if that's the case and our period is 2 pi, then that means that b equals 1. And if b equals 1, we don't really need to write it. So now with all of this information, let's go ahead and write our equation. So we should say that y equals, okay, we know that it's negative because it's starting below the x-axis, or not the x-axis, the reference line, or it's a reflection. So it's negative. We know our amplitude is 2. We know we're working with cosine. We didn't shift left or right, because it's starting at 0, so that's totally fine, so we don't have to worry about a phase shift. And additionally, we know that our period is 2 pi. So that means we're really just taking the cosine of just a regular old x here. You can write 1x, but it's not necessary. And then we shifted down 4. And so this would be our equation. Okay, so moving on to the next one. So there are multiple answers for these, but typically we're going to start them on like the x-axis, and that's going to help us out because you can actually write a cosine graph as a sine graph, but we're worried about keeping it kind of as simple as we possibly can. So again, here we want to identify where it starts, which we, again, typically are going to want to start at 0, so here. And then where that pattern starts repeating, which hopefully if we notice, okay, it starts repeating right about here. Okay, so this is one full wave of this graph without repeating any values or the shape. Okay, so that's going to be our period. So again, we can draw kind of our little reference line that's cutting this graph in half in order to help us. So that is up 2. We should note that this graph is starting on that reference line, so that means this is a sine graph. And because it's going up first, because it's going to the positive amplitude, it's going to be a positive sine graph. So next we need to figure out the amplitude. So the amplitude here is, again, this distance, or you can think about this total distance cut in half, 1, 2, 3. And so that amplitude is an amplitude of 3. And then we need to find the period. So we need to look here, and this is stopping at 4, right? 1, 2, 3, 4. So we know that the period is 4. And again, we should hopefully know we find the period by doing 2 pi divided by b. So some people are able to pretty easily look at this and figure it out. If you're not, you can solve it like an equation. So we can multiply by b and then divide by 4. And so b is going to be equal to pi over 2. And again, we don't have any phase shifts left or right because we're starting at 0, so we can go ahead and write our equation. So we would say y equals, we have a positive sine graph. Our amplitude is 3, so 3 sine. We know that b is pi over 2, but that we don't have a phase shift, so we don't need a ton of parentheses here, right? We can just say pi over 2 x, because we're not shifting left or right. And then I'm shifting up 2. And that is the test review. Good luck, guys.